Hi everyone, welcome back to BSc Chemistry Study Room. Today in this video, I am going to show you how to present domain arrange using these possible brackets. So now let's start by number 1 and then the others. So number 1, this is like a normal bracket called an exclusive bracket which has at least 2 to 3 uses. So now let's see where it is used. Used in like negative infinity to positive infinity because infinity has no end. So we introduce them in this bracket, and this is showing that from our domain or range, infinities are all included. Or for a number to be in this kind of bracket, i.e., let's say x to positive infinity, such that x belongs to real number from negative side. Let's take an example for negative 3 to positive infinity. So this negative 3 and any number below negative 3 are excluded, but negative 2 to positive infinity are included. So now let's show from positive side. Let's say negative infinity to x, such that x belongs to any real number from the positive side. Let's take an example for negative infinity to positive 3. So now positive 3 and numbers above positive 3 are excluded, but positive 2 to negative infinity are included. Let's clean and show an example for a function which negative infinity to positive infinity are included in the domain, like f of x equals to x squared. Now let's use this function to show the possible domains of the function that can be presented in this bracket. Let's draw the number line. This is 0, 1, 2, 3, 4 to positive infinity. Negative 1, negative 2, negative 3, negative 4 to negative infinity. Now test each number. F of 0 would be 0 square, which is equals to 0. F of 1 would be 1 square, which is equals to 1. F of 2, 2 squared, which is equal to 4. So each number that we test will be positive here. Let's test from negative side. Negative 1 square would be 1. Negative 2, this would be negative 2 squared to be equals to 4. This shows that from 0 down to negative infinity and from 0 up to positive infinity will satisfy this function. Therefore, the possible domains of this function would be exclusively negative infinity to positive infinity exclusively. But for infinity, it shows included since infinity has no end. Now number 2, an inclusive bracket. It is shown in this kind of bracket. So let's say, for example, we want to show that negative 2 to positive 3 are included in a domain or range. So we make a dot, closed dot. So now let's shade from negative 2 to positive 3. That means we need them in the domain or range, and they are the end point. Where this means that from negative 2 up to positive 3 are included, but negative 3 down to infinity and let's say 4 up to positive infinity are not needed. So to show this, we can present them in this bracket. Inclusively negative 2, inclusively positive 3. Or this can also be shown in form of notation. X belongs to real numbers such that negative 2 less than or equals to x less than or equals to less than or equals to 3. So this can also be shown in this form. X belongs to real number from negative infinity to positive infinity, and this sign shows as belongs to such that negative 2 can be equals to x, and positive 3 can also be equals to x. Number 3, one exclusive and one inclusive. This is exclusive and inclusive bracket. So now in this case, let's say in our domain or range, we want to show this form. Let's say we want to show exclusively -4. Then we open interval this, an open cycle. This open cycle shows that -4 is excluded in our domain or range. And let's say +2 inclusively. This will be a closed dot, that is closed interval. So now this shows that open interval is excluded, but closed interval is included. Therefore, we don't need -4, but from -3 up to 2 we need them. From +3 up we don't need, and down here we don't need them. So now we can write this as -4 exclusively to +2 inclusively, or we can show this in form of notation as x belongs to real numbers such that -4 is less than x. That means it is not up to -3, and less than or equals to 2 as the inclusively end point. Now showing all real numbers except a particular number. This shows that from -infinity up to +infinity we need them except a single number on the number line. Let's remove +1. So here we open interval the +1. So then we shade this from -infinity up, then we jump up to +infinity. We need them here. We don't need 1. Then down here we all need them. So now to show this, then we can write it as exclusively -infinity, then exclusively 1 from the negative side, then again union exclusively 1, then exclusively +infinity, this from the positive side. Or we can also write this in form of notation as x belongs to real numbers such that x is not equals to 1. So we can even write it in this form. It's all correct. Number 5, showing this from negative side union this from positive side. So now let's say we want to show that from -3 up to +3 is the end point of our domain or range. So therefore, this shows that from -2 to +2 are excluded, but from -3 to -infinity and +3 to +infinity are needed, but these are excluded. This and this included. So now let's write them in this form: -infinity exclusively, then -3 inclusively from negative side, -infinity, then -3 inclusively, union +3 inclusively as this close point, comma, +infinity exclusively. So this is how to present domain and range. Don't forget to like, comment, and subscribe, please.